Hello students and welcome back to RE7, your trusted channel for mastering physics, engineering and real-world problem solving in a clear and enjoyable way. In today's lesson, we're going to tackle a topic that many students and even some technicians find confusing at first: how to select the correct hydraulic pump based on cylinder speed requirements. This is not just theory. This is exactly the kind of calculation used by mechanics, hydraulic technicians, machine designers, and safety officers in real industrial settings. To make learning easier, we will also build a Python-based hydraulic pump selection tool that performs all the calculations automatically. This lesson is especially useful for those studying mechanics, hydraulics, industrial engineering, or anyone working with hydraulic machinery. We will combine physics, fluid mechanics, and Python programming to make the calculations simple, accurate, and automated. Understanding the real-world problem. When using a hydraulic cylinder, whether in a press, lift, or industrial machine, you often need the cylinder to move at a specific speed. To make this happen, you must know how much hydraulic flow, Q, is required, how much hydraulic power, horsepower, or kilowatt, the pump must supply. However, many students find these calculations confusing because they involve multiple variables: cylinder, bore, stroke length, extension time, pressure requirements, pump efficiency, temperature and heat generation. This is where the hydraulic pump selection tool comes in. 1. Automation of complex unit conversions. Manual hydraulic calculations are prone to human error because of the constants involved. 231 for gallon, 1714 for HP, 600 for watt. The goal: to allow the user to input raw dimensions, bore, stroke, and get immediate accurate results without needing a calculator or conversion chart. The global reach. By providing a metric, Imperial toggle, the script becomes useful for international engineering standards. 2. Dynamic component sizing. In a real-world project, you don't just buy a pump. You buy a pump that fits the speed of your task. The goal: to determine the flow rate, GPM, LPM, and prime mover power, HP, kW, required. The benefit: it prevents over-engineering, buying a motor that is too expensive and powerful, or under-engineering, buying a system that moves too slowly to be productive. 3. Integration of safety officer logic. This is the most critical objective from your professional perspective. Standard code just gives you a number. Engineering code gives you a warning. The goal: to evaluate if the calculated flow is safe for standard industrial plumbing. The benefit: it acts as a digital supervisor, flagging designs that would lead to overheating, vibration, or hose failure before a single part is purchased. Transitioning from manual math to automated code is easier than you think. You have two paths. You can either draft a detailed prompt to have AI generate your code from the ground up, or you can use AI as a code reviewer, pasting your draft to check for errors and optimize for safety. I've already prepared a robust Python script for our hydraulic calculations. Let's input it now to see how AI handles the validation and formatting. Now we're just waiting for the AI to finish generating the Python code. Once it's ready, we'll copy and paste it to test it out. Here are some real-world input examples we can use. Let's give them a try. Your inputs were bore diameter 5 inches, Stroke 60 inches. Extension time 10 second. Pressure 2500 psi. Unit system Imperial. So based on our inputs, a 5-inch bore 60-inch stroke cylinder extending in 10 seconds at 2500 psi. The program calculated the cylinder volume, the required pump flow rate, and the hydraulic horsepower. We need 30.6 gallon per minuet of flow and about 44.6 horsepower to drive this cylinder. Because the flow rate is above 20 gallon per minuet, the tool also gives us an automatic safety advisory, reminding us that high flow can increase fluid velocity and may require larger hoses and ports to avoid overheating or safety hazards. All right, team, if this lesson helped you level up your engineering skills, smash that like button, drop a comment, and subscribe for more powerful engineering tools and real-world problem solving. And tell me, what hydraulic calculator should I build next? I'm ready for your ideas.